Hello everyone, we're here. We're going to watch a video about our trig problems in the trig material that we covered right before break. The first thing we're going to talk about today is the Pythagorean theorem. So remember our a squared plus b squared equals c squared. We're going to use that today to solve for missing sides of a triangle, and we're going to use it to classify triangles as acute, obtuse, or right triangles. We're also going to review our trig functions, those trig functions. So remember, sine of theta, or some reference angle, equals opposite over hypotenuse. We have cosine of theta equals adjacent over hypotenuse. And then we have tangent of theta equals opposite over adjacent. So these are our trig functions we can use to find for missing sides. We can use to find angles with that inverse function, and we're going to use them to solve real-world problems today. This is a quick review as we prepare for an online graded assignment that you guys will have next week. So let's take a look at this problem. It says use the Pythagorean theorem to find the length of the missing side. We're going to round to the nearest hundredth. So the first thing, our Pythagorean theorem, a squared plus b squared equals c squared. The only thing that matters is our c value. We have to be able to identify our c value. So if you look here, our c value has to be the longest side of our triangle. So if 90 degrees is our largest angle, we're going to look across from that, so that 26 has to be our c value. The a and the b values are then left for the legs of the triangle, which will be the 12, and then the missing side. So we could call this a or b over here. It does not make a difference. So if I was to substitute these in, I would do 12 squared plus b squared equals 26 squared. If you guys grab your handy dandy calculators, you will understand that you need to take care of the exponents first. So if we take 12 squared, we're going to get 144 plus b squared equals 26 squared, which is 676. In order to get b squared by itself, we're going to go ahead and subtract this 144 from both sides. It'll cancel over here, and we'll be left with b squared is equal to 532. The last thing we have to do is to undo that square, so b squared. So in order to undo that, we're going to take the square root, so b will equal the square root of 532. And if you do that on your calculator, remember shift square root, or if you're on your cell phone, you can turn your phone sideways and there is a square root button, and you get 23.065. But if we pay attention to our instructions, they said to round to the nearest hundredth. So if we take our answer and we do 23.065, that means we need to have 2 decimal places, or our number is rounded to 2 decimal places. This 5 is going to make the 6 go up. So our answer would be 23.07. And that would be our final answer. If at any moment, don't forget you can pause in order to write or catch up with writing, so don't feel like you're falling behind if I'm moving a little quicker than you are. If we look here, we can also use the Pythagorean theorem to determine if a triangle has side lengths that are characteristic or that characterize an acute triangle, an obtuse triangle, or a right triangle. So we're going to use this Pythagorean theorem to classify those triangles. The first thing is still you identify your largest value. So of this, our 7 is our largest value. That has to be our c value. For number 2, 14 is our largest value. That's going to also be our c value. We go ahead and substitute our values into the Pythagorean theorem. So 3 squared plus 5 squared equals 7 squared. And we're actually going to do a quick check to see if this is actually true. 3 squared is 3 times 3, which is 9. 5 squared is 25, and 7 squared, we're going to see if that's correct, is equal to 49. So the question would be, is if we add 25 and 9, are we going to get 49? Well, we actually get 34, which is not equal to 49. So with this being the case, we have to look at our c squared value. Our c squared value is larger than the a squared plus b squared value. So since 49 is the biggest, our c squared value is the largest. So that means we're going to have an obtuse triangle. If our c squared value was smaller, we'd have an acute triangle. If it was the same, we would have a right triangle. Let's go ahead and check out our next one. So number 2, same process, 10 squared plus 11 squared. Does it actually equal 14 squared? Well, let's check it out. 10 squared is 100, 11 squared is 121, and then 14 squared, for those of you who don't know your perfect squares yet, is 196. When you add these two, you get 221 does not equal 196. In this case, our c squared value is not the largest, but is the smallest. So whenever it is the smallest, we have an acute triangle. And that would be how we classify. And once again, if these were actual equal numbers here, the 221 was equal to 221, we would have a right triangle. All right, moving forward. We can also use our trig functions to find the values of specific sides of a right triangle. The hardest part here is trying to identify which sides represent which within our trig functions. So remember, our trig functions, we said sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. I apologize for my handwriting here. I'm using a stylus, which is not the norm. We are all in this not normal classroom together. So the first thing is identify your angle or your theta. So in this case, we have this 57 right here. That's going to be our theta. Okay, so across from that, this would be the opposite side over here. But we don't have a value over there, so we're not going to worry about that. So the other sides we have to worry about are the adjacent and the hypotenuse. Remember, adjacent means next to. So this side is the adjacent, and then the one across from the 90-degree angle, that is always going to be our hypotenuse. So now that we have our sides labeled, we have to determine which function actually uses adjacent and hypotenuse. Well, that's going to be our cosine function. So we would do cosine of our angle equals adjacent x over our hypotenuse, which is 31. Once we have this, we're not trying to solve for x. X is in the numerator, so we would want to go ahead and get rid of that 31, and we want to get rid of it by multiplying. It's already being divided, and what we do to one side, we must do to the other. So we'll have x equals 31 times the cosine of 57. You can go ahead and try to put that in your calculator. So 31 times the cosine of 57, that's going to give us 16.88. So 16.88, we're rounding to the nearest tenth, becomes 16.9. So that's that first question there. Second question, we start up the same way. This time, 22 represents our reference angle. The side touching it, this is our adjacent in this case. And over here, this is across from, the 5 is across from the 22. This will be our opposite. And then in this case, our hypotenuse is the unlabeled side. So we care about the adjacent and the hypotenuse. The function that uses adjacent and hypotenuse is cosine. So we will go ahead and, the function that uses opposite and adjacent, my apologies, is tangent. So we would go ahead and do the tangent of 22 is equal to 5 over x, opposite over adjacent. This time, where's our x at? Well, our x is located in the denominator, so we're going to do that little switcheroony trick. So we'll move x all the way over here to the left side of our equal sign. We'll keep the 5 where it's at, and instead of dividing by x, we're going to divide by the tangent of 22. When you put that into your calculator, 5 divided by the tangent of 22, you're going to get 12.37, so that rounds to 12.4. We can also use our trig functions to go ahead and find the value of an angle, or in this case x is now located inside the triangle. The process is still the same. So we go ahead, find our reference angle. So this would be our reference angle. Label our sides. The 8 is located across from x, so this is opposite. The 12 is located across from the 90-degree angle, so this is our hypotenuse. If you look back at your functions, opposite and hypotenuse is, ding ding ding, that is your sine function. So you'll have sine of x is equal to 8 over 12. Now this time, x is our variable that we're solving for, and x is what we're going to need to get out of this trig function. So whenever we have x in the parentheses, we're going to do a switcheroony, but when we pull something out of the function, we're going to end up using what's called the inverse function. So I'm going to take the inverse function, I'm going to put my fraction in here, now I'm going to set it equal to x. And then in your calculator, you need to do 8 divided by 12, and then you need to do the inverse sine, or you need to do shift sine, depending on which calculator you're doing. And remember, 8 over 12 is the same as 8 divided by 12. So if we did that and we round, this time to the nearest thousandth, that means that we're going to have x equals 41.8103. For those of you who aren't quite familiar with thousands, remember this is tenths, hundredths, thousandths. So that means we're going to have 3 decimal places. So we're going to look at this 3 right next to the 0. This 3 does not make the 0 go up. So our answer here, x would be equal to 41.810 degrees. And that would be our final answer there. For the last problem on this page, same process. So x, this is our reference angle here. Remember, across from the 90-degree angle, this is our hypotenuse. And then this is actually going to be adjacent this time because it is touching the angle. So if we look here, we're going to use a function that uses adjacent and hypotenuse. So the function that uses adjacent and hypotenuse is cosine. So we'll have cosine of x equals adjacent, which is 19, over the hypotenuse, which is 27. Same thing happens. We do our switcheroony. We need to pull x out of the cosine function. So when we pull something out of the function, we're going to end up using that inverse function. And we'll have 19 over 27 in our parentheses, and we'll set it equal to x. Once we go there, in your calculator, you have to do the inverse cosine or shift cosine of 19 divided by 27. When you put that in your calculator, you get 45.275. degrees, and that would be your answer there. All right, moving right along. So if we look here, now we're going to use a trig function to solve for either a side or an angle, so we can use the inverse or the regular trig functions. This time we're rounding to the nearest tenth. And this time we're going to have some sort of situation going on here. So let's get out our handy dandy drawing skills. I know those are your favorites. And here we go. An airplane has taken off at an angle of elevation of 9 degrees. It is currently at an altitude of 1,000 feet. Find the distance along the ground that the plane is from where it lifted off. All right, well, here's our handy dandy airplane. And it's taking off on the ground, it's taking off in the air, and it's flying to an altitude of 1,000 feet. Altitude means height, so this would be how high it is from the ground to its highest point once it travels. We're taking off at an angle of 9 degrees, so that would be our angle of elevation. It's opening up from the ground. And it says find the distance along the ground, this is the ground down here, to solve for where the plane is located from where it took off. So, procedurally, we know that in our triangle, this is our hypotenuse. We know that if this is our angle of reference, that across from it, this is the opposite, and right next to it is our adjacent. We're going to worry about the opposite and the adjacent for this case, so that is our tangent function. So we'll do tangent of 9 degrees is equal to 1,000 feet all over x. When x is in the denominator, we do our switcheroonie here. That 9 is in the tangent function, so it stays with it. And we'll end up with x on the left side is equal to 1,000 feet, all divided by the tangent of 9 degrees. When you put that in your calculator, notice it said we're rounding to the nearest 10. So 1,000 divided by the tangent of 9, make sure you close your parentheses if you need to, would be 6,313.75. So if we're rounding to the nearest tenth, that 0.75 is going to become 0.8. So 6,313.8 feet along the ground is how far that plane has actually traveled. Last question here. This time it says we have a person who is 5.5 feet tall casting a shadow that is 2.75 feet tall. All right, well, if they're casting a shadow, we must have the good old Mr. Sun. Sun, Mr. Golden Sun, please shine down on me. Woo! So we have the sun shining down here. We're casting a shadow onto the ground. All right, here's our angle. And that is the angle that we are going to find. So we're going to call that theta. We know that this person over here is 5.5 feet tall, and we know that the shadow is 2.75 feet long. Once we have this here, we can go ahead and label what we've got. If this is our angle theta, this is our adjacent, this is our opposite, our hypotenuse has no value, so we're going to use tangent. In this case, tangent of theta is opposite 5.5 feet over 2.75 feet. And whenever we have to solve for an angle, we got to pull that angle out of that function, and then we got to switch over to the inverse function. So in our parentheses, we'll put 5.5 over 2.75, or divided by 2.75, is actually equal to theta. So this time, theta, or our angle, nearest tenth again, don't forget, would be the shift tangent or inverse tangent, 5.5 divided by 2.75, and when you do that, you get 63.4 degrees. Thank you for listening, and I hope you all have learned a little bit of review coming back from break. I know it's always hard to rack that brain, but please use this and work on your test review, and have a wonderful, productive day.